The User State Migration Tool, USMT, is a command line tool used to streamline and simplify user state migration during large deployments of Windows operating systems. USMT captures user accounts, user files, operating system settings, and application settings of an existing machine. It stores and then migrates them to a new Windows installation. You can use USMT for both PC replacement and PC refresh migrations. USMT enables you to do the following. Configure your migration according to your business needs by using the migration rule.xml files to control exactly which files and settings are migrated and how they're migrated. Fit your customized migration into your automated deployment process using the scanstate and loadstate tools, which control collecting and restoring user files and settings. Perform offline migrations. You can run migrations offline by using the scanstate command in Windows pre-installation environment, WinPE, or you can perform migrations from previous installations of Windows contained in windows.old directories. Identifying which components to migrate. When planning your migration, it's crucial to identify which components you need to migrate to the new operating system platform. These components may include user accounts. Workstations may have settings related to both domain and local user accounts. You must determine if you need to migrate local user accounts. Application settings. You must evaluate and locate the application settings that you want to migrate. You can gain this information when testing the new applications for compatibility with the new operating system. Operating system settings. Operating system settings include appearance, mouse actions such as select or double-click, keyboard settings, internet settings, email account settings, VPN connections, accessibility settings, and fonts. File types, files, folders, and settings. When you plan your migration, identify the file types, files, folders, and settings to migrate. For example, you need to determine and locate the standard file locations on each computer, such as the My Documents folder and company-specified locations. You also must determine and locate the non-standard file locations. Using USMT, the components of USMT include scanstate.exe. The scanstate tool scans the source computer, collects the files and settings, and then creates a store. Loadstate.exe. The loadstate tool migrates the files and settings, one at a time, from the store to a temporary location on the destination computer. Specify migapp.xml, miguser.xml, and migdocs.xml with the scanstate and loadstate commands to migrate application settings, user profile data, and user folder files to computers that are running Windows. Explore client virtualization. Most modern computers now include hardware to support virtualization. Virtualization, in the desktop context, is the ability to install an OS and applications into a logical device, as opposed to a physical machine. The most common use of this technology is to run multiple instances of computers on a single computer, and we extensively used it in server deployments. However, Windows Client includes features that allow clients to take advantage of virtualization. Client Hyper-V. Client Hyper-V is the virtualization technology built into Windows clients. It's the same virtualization technology previously available only in Windows Server. Client Hyper-V enables you to run one or more operating systems simultaneously on the same host computer. Instead of working directly with the computer's hardware, the guest operating systems run inside a virtual machine, VM. A virtual machine is a computing environment implemented in software that abstracts the hardware resources of the physical computer so that multiple operating systems can run simultaneously on a single computer. Each operating system runs in its own virtual machine and is allocated logical instances of the computer's processors, hard disks, network cards, and other hardware resources. An operating system running in a virtual machine is unaware that it's executing in a virtual environment and behaves as if it only controls the underlying physical computer's hardware. It's common to use the term hypervisors when discussing virtualization. A hypervisor is a virtualization platform, like Hyper-V, that enables you to run multiple operating systems on a single physical computer called the host computer. The primary function of the hypervisor is to provide isolated execution environments for each virtual machine and manage access between the guest operating systems running in virtual machines and the hardware resources on the physical computer. You can deploy Windows OS and applications to virtual machines running a hypervisor host, just like a standard installation. Client Hyper-V is useful for scenarios such as running an app that may require a different OS or version than the primary OS must be used, or scenarios that require an isolated environment, such as driver testing or application compatibility. Windows Sandbox. Windows Sandbox is a feature first introduced in Windows 10 that allows Windows clients to set up an isolated environment without the need to configure Hyper-V, create a Windows VM, or set up a VHD. This process enables the user to quickly start an isolated, pristine Windows environment for temporary use scenarios, such as launching a downloaded executable that you may not fully trust. Windows Pro and Enterprise editions include Windows Sandbox. Windows Sandbox includes the following characteristics. Pristine. Every time Windows Sandbox runs, it's as clean as a brand new installation of Windows. Disposable. Nothing persists on the device. When Sandbox is closed, everything is discarded. Secure. Uses hardware-based virtualization for kernel isolation, which relies on the Microsoft's hypervisor to run a separate kernel, which isolates Windows Sandbox from the host. Efficient. Uses the integrated kernel scheduler, smart memory management, and virtual GPU. To use Windows Sandbox, you must enable virtualization on physical hardware. If using a virtual machine, you must enable nested virtualization. You must also enable Windows Sandbox in Windows features. Summary. In this module, you learned about deploying Windows clients at scale. You compared the modern, dynamic, and traditional approaches to deployment, examined the benefits of imaging a device, and learned about the autopilot process and how it differs from conventional deployment methods. You explored the different deployment strategies and how they affect the end-user experience. You learned about the tools included in the Windows Assessment and Deployment Kit, and reviewed the user state migration tool components used to migrate user data during deployments. Next module describes configure storage on Windows clients.